If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where we are solving previous year IIT JEE questions on parabola. So today we will be solving 4 questions, question number 20, 21, 22 and then 23. Okay, then let's try to solve these questions. Now this one we have already solved in JEE main, and that is in intermediate level. Question number 7 you check the same question we have solved. So that's why I am skipping this one. Okay, now if you come to this one, 21 to 22, what they are asking, let PQ be a focal chord of the parabola this. The tangents to the parabola at PQ meet the point lying on the line this one. Okay, so you know the tangent to the focal chord always are at perpendicular. We have explained it in the article, perpendicular tangents. And they meet on the directrix. Okay, so if you have a focal chord this one, if you draw tangents, these angles will be always 90 degree. And they will always meet at the directrix. So this figure is clear. You take 2 points focal chord passing through focus PQ. You draw the tangents at PQ. They will obviously pass. They will intersect at the directrix x equal to minus a at an angle of 90. Okay, this much we know. Now the first question is, if the chord PQ subtend the angle theta at the vertex. So this PQ angle measuring a theta at the vertex, this angle, then tan theta. What is you are asking to find the angle? So by seeing this, you can do something. It is 90 degrees, so it will be obviously greater than 90. You can visualize it. If it is 90, then obviously this angle will be greater than 90. So if it is greater than 90, that means obtuse angle, that tan theta should be negative. So your initial intuition by seeing it, it should be either it will be option B or D. Okay, now let us try it. Because they are focal chord, T1, T2 is minus 1. So once you know this one, you can find easily this one in terms of T1 only. So now, what is my idea? My idea is, you can find this point easily because it is meeting at x equal to minus a, this line, and they are saying it is also passing through this line. So let me calculate, because this is the point of intersection of this line, the line they have given, because they said that this tangent meet at this point. We know this tangent meet at directrix, so obviously directrix is also passing through this. So intersection of these two lines also give me that point. So how to solve this line? You put x equal to this, so it is minus a comma minus a. So you got this point. So initially, before going to this, so you think how we will find this angle. So if I can find this slope and this slope, then I can find this angle. So finding this slope, because these coordinates you know a T1 and you know a property also T1, T2. Let us, before going to this, before finding this point and everything, let us see what is our need. So if I need to find the tan theta will be M2 minus this formula, M1 minus M2. M1 minus M2 by 1 plus M1. So you can see this one is where here we are applying M1. So it is, what is the slope here? If you do this one, it is 2a T1 minus 0. So you can see the slope of OP, 2a T1 minus 0 divided by 81 square divided by. So this is 2 by T1, one slope. Another slope, if you find the slope of this one, same OQ, this minus 0 divided by this minus 0. So 2 by T2. You put this here in place of M1, M2. This is M2 and M2. So if you find this one, you will start with this point, something of this. So it will be T1, T2. T1, T2 will put minus 1. T1, T2 will put minus 1. So you will start with this. So you need this value. If you need this value, then you can proceed. To finding that value, that's why we are finding this point. Because once we know this point, this is also intersection of these two tangents. We know the intersection of these two tangents is this one. So by comparing these also, you can find T1 plus T2. If you know T1 plus T2, you can find T1 minus T2 because T1, T2 is also known. So if you compare, because if this point we found out to be minus a comma minus a, which is also intersecting point of these two tangents. Intersecting point of these two tangents is given by this formula. So this should be equal to this. So if you equate this T1, T2 minus 1, that's one we already know because of focal chord. This is the extra thing that we are knowing. So if you know this one, you can find a minus b. A minus b whole square equal to a plus b whole square minus 4ab. That you can apply. So that's what is a minus b, a plus b whole square minus 4 into ab. 4 into T1, T2. So this one is 1, this one is 4. So if you do this one, you will get the answer. So your tan theta should be plus or minus, both. Because it is mod we are taking actually. So here it will be minus. So you can see this angle is obtuse angle, this angle is greater than this, so it will be obviously minus. So that is the trick. Your answer will not be C, your answer will be, which one will be answer? D. That is minus 2 by 3 root D. So that's your answer is D. So even if you solve this one, if you don't look at this angle, this angle is greater than 90 obviously. So your answer should be minus. So that is the idea. So if you come plus minus, because we take mod, because we are always interested to find the acute angle between the lines, but here it is obtuse angle. Here if you take mod, this angle is given, because if two lines meet, so they can be an obtuse angle. This is obtuse, this is obtuse, this is acute. So plus 1 is this one, minus 1 is this one, tan theta. It can be this or this both. So you have to take this one, because here they are talking about obtuse angle. Now next 22, they are asking the length of the chord PQ. So length of the chord PQ. So PQ length chord, I have not given this formula, length of focal chord, because this formula again not so required. So you can easily find what is the length of this one, under root. So if you do this one, 8t1 square minus 8t2 square whole square plus 2t1 minus 2t2 whole square. So if you do this one, if you take a common, you can take a common, and then you will see this one, it is t1 minus t2 whole square, and then t1 plus t2 whole square. Here it is 4 into a, already I have taken common, t1 minus t2 whole square. So you can take t1 minus t2 also common, so t1 minus t2, under bracket it will be t1 plus t2 whole square plus 4. So here you know all these value, you can put all these value. T1 minus t2 you have already just now calculated, it is root 5, a root 5, and this is also minus 1 square, that is 1, then it is root 5. So you will get already 5. So there is no need to remember this one, you can apply it anytime, and you can apply this formula, because if it is a focal chord, then t2 t1 is equal to minus 1. If you put this one, t2 t equal to minus 1, then this expression comes, because then t2 will be minus 1 by t1, so it will be t1 minus 1 by t1 plus 4 into t1 1 by t1, that you can write x minus 1 by x, that algebraic formula. So from here you will get t1, this one will be plus, so it will come plus. Should I solve it there? If it is a focal chord, then it becomes, this length becomes a into t1 plus 1 by t1, because instead of t2 you can write, because t1 t2 is minus 1, so that's why I am replacing t2 is equal to minus 1 by t1, and under bracket it will be t1 minus 1 by t1 whole square plus 4. So this one you know how to write it, you can write it t1 plus 1 by t1, so it will come. Now I can say it is coming, so t1 also comes, so it will be whole square, because inside also a minus b whole square, plus you can write it t1 1 by t1, so you can write it a minus b whole square plus 4ab, a plus b, so a plus b, a plus b, a plus b whole square. But here you can directly substitute the values. Now if you come to 23, the line this y equal to mx plus 3 meets the axis at e equal to 0, 3. Okay, this line is meeting at 0, you can know, because y equal to mx plus c means it is c, so it will obviously meet at 0, 3. And the arc of the parabola y square equal to 4ax at the point f. So at a point it is mixing, that is x, and your y is between 0 to 6. They have also given. Okay. The tangents to the parabola at f. This tangent to the parabola meets the y-axis at g, so it is mixing at y-axis at g. The slope of the line L, this slope of the line L is chosen such that the area of the triangle EPG has a local maxima. Local maxima means if you differentiation is required, it means if you can differentiate, then you will find a maximum point, that is local maximum. Okay, so now let us take, because we need to find this point and everything, so let's take this point where it is meeting, it is 40 square comma 80, that because a is here 4, so 80 square 280. So the equation of the tangents, what is the equation of the tangent? y1, because ss1, and then 2 into 2 will divide it, 8 into x plus x1, so if you put it, it is like this. So it is meeting at y-axis means x equal to 0, if you put x equal to 0, then y is equal to 40. So this point you know, 0, 40. So this point you know, this point you know, this point is given. So you can find the area of this one in terms of t, because you have to maximize the area, you have to get a local maxima. From that you will find the value of the t. Once you know t, then all the points are known. So you find the area in terms of t. So 3 points are given, and this one you can see, if you take this is a base, then this is a height. So what will be this height? It will be 40 square, because this is the height from here to here. So this is 40 square. What is the base? Total is 3, and this height is 40. So 3 minus 40. So 3 minus 40 into 40 square, half. So the area is this one. 3 minus 40 into 40 square, half. So if you do, this is the area. Now for getting maximum, what you are doing, you are differentiating this with respect to theta, that is del dash. So if you differentiate it, those who don't know, just bear with me. So it is 12t, 24t square. If you differentiate it, t cannot be 0. If it is 0, then everything comes to the origin only. So obviously t is equal to half. So if that means you are getting maxima at t equal to half. No need to check whether it is maximum or in 12 we will differentiate it one more time. If you differentiate it, it will be 12 minus 48t. So if you put this point t equal to half, then it is negative, so obviously t equal to half is maximum. So no need to do, because they told you to find it, there will be maximum. If there had it been there one more t, then you are confused which one is maximum, which one is minimum. Then you have to check after in the second differentiation which t is giving you negative. That t will take as a maximum, because only one t is left, so you know this is the maximum. So you know all the points, you know f, you know g, all these points are given to you. Now just you have to match. The first one is the m, that is the slope of EF. So what is the slope of EF? EF, E and F. E is already given 0,3. So y2 minus y1 divided by x2 minus x1, that is 1, which is 4. So it is true. They have given also true. So next one is what they are asking. Delta max. What is the maximum area? So area is this one. You know this one. For maxima you need to put t equal to half. If you put t equal to half, you will get maximum. So you put t equal to half there. So this is also correct. Next is y0. Y0 was the coordinate of the G where it is meeting. So now it is the coordinate of f, x0, y0. This was the x0, y0. So this is 4. You already got it. It is matching. Means with m it should be come to 1. Option 4, slope is value is 1. With max it should come to half, this one. That is, you know, these are the options. That means P will be connected to 4, Q will be connected to 1, R will be connected to, S will be connected to 3. S is equal to y1. All these values you can connect it. If you like the video, then press the like button and please give your valuable comments in the comment section.